Good morning. So in this video, I will record a review of the Bed Reactor uh, solution using Polymath. If you still remember, um, we'll be using two differential equations, and then basically you will just input uh, the values of the constants, no? And then basically you run the Polymath program. And then also on Thursday, I will post your prelim exam. So we're going to have an exam on Thursday on our scheduled time. That is 2:30 to 4. So if you're going to miss the prelim exam on Thursday, that would be May 28th. There will be another set later. It will be announced also later. So the preliminary exam will be all about Bed Reactors. Okay. So remember, this is just a 1-unit course. So we just meet once a week. So basically, we're just going to discuss two more topics, one topic for the midterm and another topic for the finals. So after each video, we're going to have the major exam. So I'm going to shoot another video for the midterm, and then the exam for the midterm will be available, and then I will shoot another video for the final, another topic, and then the exam for the finals will be available. So let's continue with the review of the Bed Reactor. I'm going to share the PowerPoint. Okay, so this is, if you still remember, this is the first equation uh, that we're going to use for PVR calculation or for PVR design. Basically, for PVR, if you still remember, you just need to calculate the weight of the catalyst. And then basically, if you know the density of the catalyst, that's going to be the volume of the Bed Reactor. So, ganun lang kasimple. And then, kung natatandaan nyo, dalawang differential equation lang naman yun. So this is the first differential equation. If you still remember this is similar, quite similar to a PFR, no? So ang PFR naman is quite similar to a batch reactor. So that's how we arrive at this equation right here. Right here. This is dx, dw. X here is the conversion, no? And then W is the weight of the catalyst. And then RA prime. RA prime is the rate of the reaction as opposed to RA, which we use on batch and even CSTR and even PFR. So pag RA prime, if you still remember, this is based on the weight of the catalyst. Yun lang naman yung difference. Pero basically, this is still the weight of the reaction based on A. And then we have FAO right here. So FAO is the molar flow rate of initial molar flow rate, of substance A that goes into the PBR reactor. Remember, a PBR reactor is also continuous, just like a CSTR and a PFR. Yun nga lang may catalyst siya. Okay, so this is the first differential equation that we're going to use to solve the PBR problem. And then as you can see, this is just derived from an equation similar to a PFR or similar to a BATS reactor. Okay? So let's go to the second equation. So the second equation is derived from the Ergun equation. So if you wanted to review the Ergun equation derivation, you can watch on the videos before this, So this is the derived Ergun equation used for PBR. You can also see the derivation from Pagler. Okay, so as you can see, this is quite simple. We only have alpha. So alpha is a constant generally given in a problem, no? Or in case you wanted to design a PBR, you just look for the references to find alpha. So this is, if you still remember, this is the constant of the Ergun equation that are combined to form this single constant, no? So this is alpha, and then this is number 2. This is 2. This is number 2, and then this is y. If you still remember y is the ratio of the actual pressure to the initial pressure. Kasi generally, we use PBR equation for gases, and the pressure is changing along the length of the PBR reactor. So, yung concentration and also the conversion depends on the pressure. So, if you still remember, Y is equals to P over P sub O. P is the actual pressure and P sub O is the initial pressure. This is the initial pressure of the feed, no? Excuse me for a while. I'm just going to check the connection. Car, pasaksak nga, Karen. Sa likod. Nagre-refer lang. Binunod eh.
Hindi ka rin narinig. Oh. Walang space.
Hindi, meron pa dyan. Tagalin mo yung USB. Wala. Okay, so this is the second differential equation that we're going to use. So generally sa problem, you're given alpha, and then ayun, ito yung initial ng x 0, tapos yung initial ng y 1 kasi pag initial yung initial pressure nyo is equals to p sub 0. So initial y is also equal to 1. Tapos we're going to calculate epsilon. You still remember epsilon? So epsilon right here is the change, in the volume of the reactants, or the change in the volume of the system. So basically, we're going to compare initial and final to get epsilon. You still remember the formula for epsilon? Okay. So this is the formula for epsilon, if you still remember. This is from Liebenspiel. If you still remember, Liebenspiel uses volume, volume of the system when conversion is equal to 1 minus volume to system when conversion is equals to 0, divided all over the volume of the system when conversion is equals to 0. So if you still remember, in Pagler, this is more practical. Pagler use the more practical equation. In Pagler, you have this is also equal to number of moles when x is equals to 1 minus number of moles when x is equals to 0 divided by number of moles when x is equals to 0. Still remember this fractional change in volume epsilon. So for example, you have a a plus bb will give you cc. So initially you have a plus b, di ba? As your n sub x is equals to 0, and then only c will remain when x is equals to 1. So from this reaction, the epsilon would be equal to c minus a plus b divided by a plus b. Okay? So I hope you still remember this fractional change in volume. Nagiging complicated lang to if you still remember pag merong non-reactive components, Pag may non-reactive components. Pag may non-reactive components, i-carry nyo lang yun from reactant to the product. Of course, I hope you still remember how to do that. And then let's tackle another equation. So this is the conversion equation in gas reaction. Just to remember this. So basically yung Ca over Ca over initial concentration of A, Ca over CaO, this is also equal to FaO divided by B. So yun yung original equation dito, FaO divided by B. And then, dun base yung definition ng nung conversion, FaO sa FaO. So that's why meron kong 1 minus XA, tapos sa baba, nagkakaroon ng 1 over E8 over times XA, Tandaan niyo pa ba? Basically, yung CaO times 1 minus XA, yun yung FaO. Anyway, we just try to recall this equation. And then, in the case of PBR, since the concentration is varying with pressure, sa PBR, we added a Y term here. So, you need to multiply this by the Y term, by the pressure term, the pressure ratio. So, ganun lang naman yun. So, even if it's CB, it will become CB over CBO is equals to 1 minus X sub A divided by 1 plus BA XA times Y. So, ito yung gagamitin yung isa pang equation sa Polymath, para makuha niyo yung value ng CA at saka ng CB. Okay, so basically yung apat na equation na yun yung gagamitin natin. And of course, syempre alam niyo na naman siguro yung halimbawa RA, yung equation ng RA. So usually naman ang binibigay ng mga reaction dito elementary. So pag sinabing elementary, kung ano yung stoichiometric coefficient, yun yung magiging power nung reaction. Halimbawa, this is the reaction A plus B, D. Okay. And then the product would be CC. This is general reaction, ano? D ang product. So, pag elementary to, this is just equal to negative K C sub A, di ba? Raised to A times C sub B raised to B. So, of course, this is, alam niyo na naman siguro to kasi since dyan kayo pa pinag-aaralan na to. Okay? So, let's go to the problem. Let's tackle the problem. Okay, so this is the problem. Gas phase reaction in TBR. So the reaction A plus 2B will give you C. Is carried out in a packed bed reactor in which there is a pressure drop. The field is stoichiometric in A and B. Kapag sinabing stoichiometric, kung ilan yung ratio sa reactor, sa reaction, yun din yung available ratio sa feed. So, for example, in this particular case, for every in the reaction, you can see that for every 1 mole of A, you need 2 moles of B. So, halimbawa dito sa problem na to, if the CaO is 0.2, CBO would be 0.4 times 2 lang. Ano? Kumbaga parang walang excess tsaka walang limiting. Sakto lang yung amount nung reactants. So the initial pressure is 10 atmosphere and then the initial flow rate of A is 2 moles per minute. That's your FAO. Remember, you were going to use that dun sa first, we need that constant dun sa first differential equation, the FAO. Okay? So you are asked to plot the conversion and pressure ratio. Y is equals to P over P sub O as a function of catalyst weight up to 100 kg. So, tandaan nyo pa to sa Polymath, i-define nyo from yung W from 0 to 100 kg. So you are asked to plot the conversion ratio Y as a function of catalyst weight W. Additional information, the constant of the reaction is 6 liter or decimeter to the 9 per mole squared per kilogram per meter per minute. And then alpha is given to be 0.02 per kilogram. Okay, so let's try to solve this problem. So basically in Polymath, you can proceed to Polymath and then you just input the two differential equations. Now, so after inputting the two differential equations, you just plug in this constant AA, alpha, FAO, okay, CAO, P sub O, okay. So that's basically how to solve this problem. So let's proceed to One thing that you need to solve right here is the epsilon, Kasi, di ba, you're going to use the epsilon in one of the differential equations. So that's going to be your F's. So epsilon, in this case, remember epsilon is simply, let's solve it over here. So epsilon is simply number of moles when X is equals to 1 minus number of moles when X is equals to 0 divided by number of moles when X is equals to 0. So, when X is equals to 1, it's going to be 1. No? Kasi wala naman tayong inactive reactant or inactive ingredients. Wala tayong inert, Wala tayong inert. So, the product is on 1 mole, So, epsilon basically equal to nx is equals to 1 is 1 minus nx is equals to 0 is 1 plus 2. 1 plus 2, that would be 3. So minus 3. Tapos divided by 3. Nx is equals to 0. So epsilon is equals to negative 2. So this is another concept that we're going to use in solving this problem. Ano? So I guess that's the only thing that you need to calculate in this particular problem. Tapos ano na, polymath na. Just try to recall ano how you ito usually yung ano mahirap dito sa PBR. How to find the epsilon. And in some cases how to find hindi ka mukha ito kasi given lang yung CAO dito. In some cases pag may inert medyo mahirap din hanapin yung CAO. Okay? So let's open up our let me share you my polymath. Okay, just remember using how to use the polymath. Basically, first step is you click on file, then you click on program pala, and then this one, differential equation, DEQ. So just click on the DEQ. Okay. So after clicking on DEQ, let's enter the differential equation. This one. So let's enter the first differential equation. So yun munang yung dx dw negative RA is equals to negative RA FAO. So dx and then right here we have w. Tapos may negative 1. So let's enter negative 1. Tapos if you still remember times is just star times R sub A, RA, and then all over FAO. So divided by capital F, I'm going to use capital F A O. This is just a constant. So that's it. The initial value of X, the initial conversion value simply is 0. Okay, so just click on done. And you see you will have this first differential equation. And then next, the different. This is, as I've said before, this is based on this equation is similar or derived from the Bat's reactor, from PFR, just similar to those equation. It's just based on the weight of the W is the weight of the catalyst. Okay, so let's add the another equation based on ergon, the ergon equation. So the ergon equation is dy dw. So let's type in y over there. Then negative alpha, so negative 1 times alpha. So probably just type in alpha. And then divided by 2. And then divided by y. So y is the ratio of the pressures, P over P sub O. Tapos times, so that would be star. Tapos 1. Shift plus. Tapos epsilon. So just type in Eps. Okay. So times the conversion X. Okay. And then the initial value of y is equals to 1. Okay. So just this is the second equation, So this equation is the ergon equation, the differential form. Alpha is just the constant of the ergon equation. Okay, so just press done, and you will have the second equation in the polymath. And then you should define all the constant using you're going to add the as explicit equation. So just click over here, explicit equation. So first, let's enter the value of alpha. So alpha is equals to 0.02. 0.2, sorry, 0.2. So alpha is 0.2. Okay, and then just click done. There we have the first constant or explicit equation. And then let's enter the value of epsilon. Epsilon, yung kinalculate natin kanina, it's negative 2/3. So just click the explicit equation again, and then type in eps, and then enter negative 2/3. Okay, done. So basically, isa-isa nyo lang yung mga constant dito hanggang maipasok nyo lahat. And then the last constant is FAO. Let's enter FAO. FAO, that's capital FAO, is equals to 2. Let me check that before. Okay, so 2 moles per minute. Okay. Okay. So as you can see, right now, we need to calculate R sub A. So we need to enter the explicit equation for R sub A. If you still remember, let me see if I can annotate this. I can annotate right here on the screen. So the equation from the PowerPoint is A plus 2B gives you C, Ayun na. So this is the reaction. A plus 2B will give you C. So assuming that this is an elementary reaction, so if this is an elementary reaction, the rate of the reaction with respect to A is negative K sub A times C sub A times CB squared. So we're going to enter this equation on the polymath. So this is our polymath. We just stop annotating so we can enter it. Just click the explicit equation. So just type in R sub A. I use R and small letter A for R sub A right here. And then I type in negative K sub A. Did I use capital K for the constant? Hindi ko pa pala napapasok yung ano. Anyway, I'm just going to use capital K and A. It is the constant. Tapos times CA. They use capital C. Okay, I'm not using any CA yet. I use capital CA times capital CB. And then squared. In order to enter squared, you just the i-caret, ano? So this is the equation for the rate. Just click in done. And then as you can see, we're going to enter the value for K sub A. Just to remember that would be 6. No? That would be 6. So let's enter that explicit equation. K sub A, capital K A is equals to 6. Okay, done. And then we need to have some equation for C sub A and C sub B. So dito natin ipapasok yung C sub A is equals to 1 minus XA. So just use some uh, that one, as 1 minus X. This is the conversion. We use small letter X for conversion, di ba? Tapos divided by uh, 1 plus epsilon, no? 1 shift F's, okay, times X. Okay, and then you need to multiply this by Y and also by CAO. So our CAO is capital C. Okay. We have not yet defined the CAO, so let's use capital CAO. Okay. So if you're going to enter this equation, we have not close this in parentheses. Okay. So as you can see, we need to define CAO for this equation. So CAO is 2. So just enter that the value of CAO is 2. From the problem, Ay, 0.2, sorry, 0.2. Okay, CO is 0.2. This is modify this one, 0.2. Okay, and then also we also need an equation for CD. So we'll enter another explicit equation, this time for CB. So C, which is capital C. Capital CB is the same, It would be capital CBO, okay, times parentheses 1 minus X, okay, divided by 1, sorry, parentheses 1 minus 1 plus epsilon times X, okay. See, and then don't forget the Y times Y. Okay, so if you're going to use this equation, you need to define the value of CBO. And then since the reactants are present in stoichiometric ratio, CBO would be equal to 0.4. So let's add the value of CBO. That would be capital C, ano? And then this is equal to 0.4. Okay? So yun. So the final step is to enter the initial and final value of W. Usually the W or the weight is the denominator of the derivative, ano? With respect to the W. So ito yun. Kung usually W yun, yun yung ating Y, ay yung X natin. Okay, so initial value ng W is 0. Okay? And then the final value ng W ay 100. Yun. So pag you'll be able to get this violet arrow, means that it's ready to run. Ano? This one. So just click in run or solve, and you're supposed to get the solution. Kung minsan pag medyo matagal, probably you need to look for some error. Baka meron kayong kaligtaan. Mga negative signs. Ito. So, pag ganyan, so just stop this. Control C. Control C. I think this is, ito lang. Usually nagkakaroon ng problema. So just enter -1 times. Dapat puro blue. May red kasi yun eh. Pag may red, may error yan. So probably yan lang naman. So just, we'll run it again. So yun pa yung isa. Kailangan. Just use Control C to override yun. Ito pa yung isa, baka ayaw din yan nito. -2/3. Pero wala, hindi naman siya blue. FAO2, K6, alpha is 0.02. Let me check that. Alpha is 0.02. Let's try alpha is 0.02. Probably it's a typo error from from Powder. Alpha is supposed to be 0.02 only. Okay, let's run it again. Yun. So, yun. So, that's it. So you can check the graph kung ano man tama. 85% yung X na maximum. Let's check the windows. Okay, so this is the graph. Let's take a look at the graph. Okay? So the green one is this is the conversion. No? This is the conversion. So as the weight increases, the conversion also increases. The blue one is the pressure. So since the product has fewer number of moles, the pressure as the conversion increases decreases. This is the pressure ratio. So mukhang logical naman to, ano? Okay. So, halimbawa, you are asked what would be the weight of the reactant if the conversion is around, say, for example, 70%. So, yun, 20, ano? Around 20. Pero syempre, kung gusto mong mas eksakto, you go to the, ano, you go to the numbers na parang yung data talaga. So, halimbawa, 70% conversion, you go right here. And then find x is equals to 0.7. No? Ito yun. Diba? Let's annotate. Okay? Ito yung 0.7. It's really up to you kung gusto niyo mag-interpolate. Pero pwede naman siguro hindi na. Ayan. Kunin nyo lamang to. Ano? So, the W would be approximately equal to 19. No, 19 kilogram. 19.32 kilogram. Ganun lang. Ganun lang siya kasimple. Okay? So, parang ganito rin lamang yung ano nyo, yung prelims nyo. So, reviewin nyo lang muna to and then take the prelims on Thursday. Mga oras yan sa Thursday. The prelim would be available on Thursday sa time schedule natin. Ano? CHE 172 for 1.5 hour, 2:30 to 4 on Thursday. That would be May 28. No, 2:30 to 4. PBR lang. Let's check kung tama yung ano natin, solution natin. So ito yung solution. Ayan, 0.85 yung maximum conversion na tama naman siguro. Tapos ito rin yung graph. Ito rin yung graph natin, x and the y. Tama naman yung ginawa natin. Ano? Okay. So today is Tuesday. So try to study this topic, ano? Bed Reactor. Sabi ko naman sa inyo, ito yung pinaka-importante dito kasi lahat naman ng reactor may catalyst naman. So PBR talaga yung pinaka-useful. At saka yung Polymath solution, differential equation solution, yun talaga yung pinaka-useful sa industry. So, yun, ganun lang naman. Simple lang. No? Dalawang differential equation, tapos pasok nyo lang yung mga values ng constant. Ang i-calculate nyo lamang is epsilon, o kaya naman kung minsan kailangan nyo mag-calculate ng CAO, CBO. Yung value yung tatlo lang na yun. Ano? So just be careful. So sa exam, probably scan nyo yung solution, tapos attach nyo, tapos yung ano padala nyo rin. Ano? Yung Polymath file. Yun, 1.5 hour exam. So, dun lang yun sa specific time na yun pwede. Ano? May 28, 2:30 to 4. So if you're going to miss that time schedule, meron pa uling there will be another set later. Most probably by June 1 naman, kung hindi nyo pa makukuha ngayon, by June 1 naman, GCQ na, madali na kayo makakabili na. Wala kayo doon. Okay, so for now, ano, hanggang dito na lang muna tong ano, tutorial na to. Okay, see you later sa susunod na video.